Hi everyone, and welcome to this new Microsoft Reactor session, DevOps in the era of generative AI. I'm Carlotta Castelluccio. I'm a cloud advocate in Microsoft, and I'm focused on artificial intelligence technologies, so everything around Azure Studio, Azure Platform, and services. This session is a first one of a series of sessions, Microsoft Reactor session dedicated to, DevOps and AI. The series is called Spotlight on AI in your DevOps lifecycle. And in this slide, you can see the link to the whole series if you would like to, check the upcoming episodes. Now, speaking about the development lifecycle and large language model operations, I would like to start with a reflection. So the development lifecycle has witnessed a significant change with the advent of large language models and generative AI-empowered solutions. We basically moved from classical machine learning solutions where we're used to train a model with specific statistical algorithms and our own data to deliver predefined outcomes. We moved from a pattern like this towards a large language model based solution where we add our own data to a pre-trained large language model together with our prompt written in natural language to get outputs which are not predefined because these models are non-deterministic. Now, such a change has larger implications not only on how we build applications, but also in how we test, evaluate, deploy, and monitor them. Basically, the whole development lifecycle. And this paradigm shift led to large language model operations, which is similar to the concept of machine learning operations, but applied to large language models. And now there are several differences between machine learning operations and large language model operations, which are summarized in this slide. Those differences include, first of all, the target audience which developed this kind of application. Traditional machine learning applications were developed by data scientists, so specialized on statistical algorithms and focused on data science kind of workflows. Nowadays, large language model based applications are have a much larger target audience, which basically includes developers of all programming languages. We also have different evaluation metrics for this application because from traditional machine learning kind of applications, we could compute the difference between the actual prediction and the actual value, and the prediction. Either the label or a value in case of regression, for example, but still we were able to compute this distance and express this in terms of an accuracy score or a loss score. With large language models, we don't have ground truth, so we cannot compute these kind of distances. What we can do is evaluate the coherence of the responses of the model or the relevance with respect to the user query or its clarity. So there are different evaluation metrics. And then there are also different risks associated to this kind of models, which are more powerful, have more capabilities. We know that large language models can produce fabrication, so can produce incorrect information or in some cases even offensive messages. So at the end of the day, the models behind the apps are different. And let's look into the large language model operations lifecycle. Let's look at this new workflow. So the life cycle is quite complex and anything but linear. It's an iterative process, like all the process related to software development, I would say. DevOps, MLOps, they are all iterative process. And now for large language model operations, we have identified 3 primary loops that you can see in this slide, all unified by 4th overarching loop. So the first loop or phase is the ideation and exploration one. And this phase is about experimentation. So here a developer delves into a large language model catalog, aiming to understand how large language model prompts engage with data. They test and validate business hypotheses, seeking the best matches for the project requirements. Then we have the building and augmenting phase, and this is where you as a developer will be spending most time and energy. Here developers refine large language models, aligning them to specific enterprise needs, and through a pattern known as retrieval augmented generation that you might have heard as RAG, they link models to enterprise specific data. So it's a dynamic phase in which when outputs aren't accurate, developers should go back, experimenting with different prompts or with different models, or even fine-tune, in some cases, large language models. And the most important thing of developing AI application is making sure that the application has high quality results, and evaluation is very core to it. So once you are done with evaluation, in the sense that the metrics you get, you are satisfied with the metrics you get, you can then hand off to the next stage, which is operationalizing or operationalization, which is basically the deployment stage. But it's also about monitoring and filtering your application in production. So in this phase, we ensure that large language models are easily integrated into systems, they operate safely, and any harmful content is filtered out. And overarching all the three loops, we have the management loop, which focuses on governance, security, and compliance. But let's go deeper and let's zoom into each and every loop. So if we zoom into each loop, this is what it looks like. In the ideation phase, we basically identify the business use case, we connect the model to relevant data, and we build a solution to harness the data effectively. Then moving into the building phase, we iterate on our model by running it against increasing volumes of data, refining our prompts and tools based on feedback, until we are satisfied with the performance, leading us to the operationalizing phase, where we deploy the solution, ensure robust monitoring and other systems are in place and fully integrated into our business application for real-world use case. Now, a similar technological paradigm shift necessarily requires innovation in the tools we use to develop, to test, and release generative AI applications. So several new tools have emerged in this context to facilitate developers building intelligent applications, and other tools have been updated accordingly. So in this session, we're going to cover the main tools in the Microsoft ecosystem for a code-first experience in the large language model operations lifecycle. First of all, Prompty, which is a language-agnostic asset class for creating and managing prompts that has been recently announced at Microsoft Build 2024. Which is, the main event for Microsoft with big announcements from the product groups. And then we have the Azure Developer CLI, an open source tool that provides developer-friendly comments to initialize a project, provision Azure resources for that project, and then package and deploy an application to the cloud. So, and lately at Build, it has been announced the creation of a collection of AI project starters that can be used as templates for further customization to kick off with a couple of comments, but we'll see these in a few. And then we have the AI orchestrators, both tools such as PromptFlow, but also frameworks such as Semantic Kernel and LangChain to enable a smooth integration of large language models into intelligent applications and to manage the end-to-end development lifecycle. Now, in addition to those tools, which are mostly focused on AI development workflows, there's also the standard tools supporting the developer journey. For example, the IDE, Visual Studio Code, the Azure platform, the cloud services, and GitHub platform for things like versioning and building continuous integration, continuous deployment pipelines. But let's start with the new tool, Prompty. Now, Prompty is a language-agnostic prompt asset class and format for creating prompts and engineering the responses. It has three main components. First of all, the specification, which is a standard format common in Markdown file template that unifies the prompt and how it is executed into a single asset. Then we have the tooling. Through a Visual Studio Code extension, we can access all the tools, including things like syntax highlighting and variables validation, but also more complex stuff like code and evaluation generation. And then we have the runtime. In fact, a prompty file as a standalone file can't really do anything without the help of a runtime to execute it. And the runtime is the whatever engine that understands and can execute the format, which includes prompt flow, LangChain, and semantic kernel, which means it actually works with both Python and C#. So on the right side of this slide, you can see how a prompty file looks like, but I know it's tiny, don't worry, we're going to see it better directly in the IDE. And the main benefits are summarized on the left side of this slide. So first of all, it provides an easy to start code-first experience and an intuitive format. It currently supports multiple languages like Python and C#, but it will be extended to more languages. I think the next one will be JavaScript. It allows observability through tracing facilities, and it is compatible with several frameworks like we already mentioned, semantic kernel and LangChain. Cool, so let's get started with Prompty. So let's go to our first demo, and for doing so, I'm going to bring up my Visual Studio Code environment in here. So the first thing we need to do is download the Prompty extension. So if I go into my extension in here, I can type in the search bar Prompty, and I can look for the Prompty Visual Studio Code extension, which is this one. I have it already installed, but you haven't installed it yet. You can install it from here. So once you have this, you can simply right-click on the in your project folder and then click on New Prompty. And this command will create basically a template for a Prompty file I can then customize further. But the cool thing is that I don't have an empty file. I have a template to start with. So let's look at the format of this file first of all. So at the top of the file, I have some metadata basically in a YAML format. I have the name and the description of the project. I have the authors, and then the model configuration and parameters, and a sample input. And then scrolling down, I also get in a Markdown format, I also get the prompt specification. So you can see here that I have the system message. In this case, for example, the specification for the persona that the assistant should use. And then I have some dynamic prompting in which you see I'm going to basically add the name of my customer that I have in here in the sample input, but in an application I might want to retrieve from my data source, and then I can add dynamically some context and the chat history basically. And the cool thing about Prompty with respect to other template engines is that you not only can basically create your doing some prompt engineering, but you can also test it within Visual Studio Code. So let's try, for example, to summarize a few fields in here. For example, I'm going to put my name as author, and I'm going, of course, to add my my parameters for my Azure OpenAI endpoint. So let me put my endpoint and my deployment name in here. Great. And then the other thing I can customize, for example, is the sample input, putting my name as a customer, and then I can save. So now I'm ready to execute this prompty file and see the output, which is basically the result of my model when I submit as this file as input. So let's inspect the output. As you can see in the output terminal, I can see the response of my model, which is, oh, sorry, I didn't show you the question. So the question is, what can you tell me about your tents? And the context is, the Alpine Explorer tent boasts a detachable divider for privacy, numerous mesh windows, and adjustable vents. So I basically have a description of one tent. I'm giving a description of one tent that might be, some context that you are retrieving from your data source, and then I'm asking this question. And so the answer is grounded in the context, and it is providing what I'm looking for. So a description for the tents offered by this fictions company, and in particular the description for this product, the Alpine Explorer tent, which I have provided as context. So that's about Prompty. Another cool thing I would like to showcase to you is that you can also integrate these smoothly in different frameworks. So if I right click on the file, I can add it to PromFlow code, to semantic kernel code, and to a LangChain code. So if I click add to PromFlow, what I get is a Python file, which I load my Prompty file, and I'm going to integrate it into Flow. But we are going to see more later. Just wanted to show to you that how easy it is to integrate it into different frameworks. So let's jump again into our into our slide deck. And let's go to the next tool, which is Azure Developer CLI, and in particular the templates. So the Azure Developer CLI command line interface provides a unified tool for managing Azure application lifecycles from initialization up to deployment. In a way, you can provision cloud resources, initialize your project, package and deploy your app into the cloud, managing the connection between your local environment and your cloud environment with simple unified commands. For example, the azd app command that you see here and that we are going to use in a second basically provision the Azure resources for your application and then also deploy your project into a single unified command. Now, one key concept in DevOps is making repeatable, scalable deployments by packaging our application and building continuous integration, continuous deployment pipelines. All of these is simplified by using the Azure CLI, the Azure Developer CLI, which seamlessly integrates with GitHub Actions in a way that basically we can build a workflow in a way that every time we push an update on a selected branch of our repo, we start this workflow to do a new release of our application on the cloud. And in addition to that, at Microsoft Build, it has been announced a new collection of AI project starter templates with samples for popular application scenarios and framework integrations, including a variety of architectural solutions to leverage Azure for AI deployments. And all of them comes attached with a GitHub Codespaces configuration. If you're not familiar with GitHub Codespaces, it's simply a dev container in the cloud. And can be deployed to Azure from within Visual Studio Code by using the Azure Developer CLI. Oh, a good thing to know is that GitHub Codespaces is free with the cap of compute usage and memory usage, but which is enough to, for example, work on some of the samples in this collection. So let's move to demo again, and let me show to you the Azure AI templates I've just presented. So this is basically a Microsoft Learn collection containing a few AI project samples, and you can see they are grouped by category of solution. So I really encourage you to explore these samples and leverage them to start your own project. For the sake of this demo, we are going to explore the Contoso Chat Retail Copilot with Azure Studio and PromptFlow project. So if I click to this link, I'm redirected to the GitHub repo that hosts the sample. And the README file of every sample basically includes some detailed instructions of what this sample is. In this case, this is a copilot-like experience, so built with the RAG pattern, which is augmented with data which are basically items from a product catalogs for a fictional company, the Contoso company, selling products for hiking equipments and clothes, basically. And so you can find a description of the solution, but also the architecture diagram. You can see here that we have in the architecture diagram AI Studio, Azure OpenAI services for generating the responses and for embedding purposes. We have AI search, we have Cosmos DB, and then you can also find, the step-by-step instruction to get started with this sample. So the prerequisites you need, and different options to set up your environment. My favorite one is using GitHub Codespaces because you already have a dev configuration, so you don't need any to install any prerequisites locally. You can start by simply basically clicking on this button, and from here you can create your GitHub Codespaces on top of the main branch. I have it one already, so I'm going to jump directly into it. And the cool thing is that you can use your GitHub Codespaces within Visual Studio Code. So in here, basically, I'm into my GitHub Codespaces. And what I should do to get started with this sample and all the sample in this collection is simply authenticate to Azure. So using the command azd auth login, use device code. And then I will be provided with a code, and I will be redirected to this web page in a way that I can paste my code and then select my Azure account. I will be also, this is, multi-factor authentication, so I need to finalize my login from my mobile phone. And once this is done, I can basically come back to Visual Studio Code, and I will be logged into Azure now from my developer environment, from my GitHub Codespaces. And so the next thing is just using the azd app command, which is going to create a new environment for me that I can name, for example, Contoso Chat. And then you can see here that I can select the Azure subscription to use, because in my case I have several subscriptions. And then I will be asked also to choose, for example, the cloud region where I want to provision my resources, and that's it. I think anyway, it's a very easy and guided process that lets you provision all the resources and then deploy your application on the cloud. I'm not going to do that just because I've already done so I want to showcase to you basically the result. And for doing so, I jump on the Azure portal and look at the resource group created by the AZD app command, which include an Azure AI hub and an Azure AI project, the Azure AI services to consume generative AI models, and application insights for monitoring, and then a machine learning endpoint that we are going to see in a moment, a Cosmos DB with the information of our customers to provide a personalized customer experience in chat. And then we also have a key vault for managing secrets and credentials. And then if we go to the next page, we can see that we have in this resource group also an Azure AI search index, which includes, the items of our product catalog, and a storage account for data management purposes. And then if we go into the Azure AI Studio, we can also explore the Azure AI project details. You see here that I have my Azure AI project with its corresponding hub. And if I click on the project, I can also investigate the models and app deployments that have been created by the AZD app command. So if I go into the deployments tab, I can see that in here I have 3 Azure OpenAI models, GPT-3.5 Turbo that I will be using as a chat engine, GPT-4 for evaluation, and the embedding ADA that I will use for the vector search. And then I have my app deployment. And if I click on my app deployment, I can see more information about this endpoint. And I can even test it with, a sample input. In this case, for example, I'm submitting a question. Tell me about hiking shoes, an MP chat history, and a customer ID equal to 2 because I want to provide, a personalized customer experience. And again, I'm the user. I'm in the use case of my hiking shopping assistant. And in a few seconds, I get the output, which is the answer to my question, grounded on the customer information and the product catalogs information. Great, so let's now come back to the deck. Let's go to, so I didn't show you the code of this solution because I would like to cover prompt flow first, since we are going to use prompt flow in this solution. So what is prompt flow, first of all? Prompt flow is a suite of development tools designed to streamline the end-to-end development lifecycle of large language model-based applications, from ideation, prototyping, testing, and evaluation up to production deployment and monitoring. It makes prompt engineering much easier and enables you to build large language model applications with production quality. Now, prompt flow is accessible through Azure AI Studio, where you can develop a flow diagram, test it, and evaluate it through a user-friendly graphical user interface. But it also provides a code-first experience as a Visual Studio Code extensions and SDK, which is what I'm going to show you today. So the main concept of the prompt flow tool is indeed the flow. Flows are executable workflows consisting of 3 parts. Inputs, which represent the data passed into the flow, and nodes, which represent the tools that perform things like data preprocessing, task execution, or algorithmic operations. So they might be a connector to an LLM, a database, a prompt definition, or even a custom Python function. And then we have the outputs, which are the result of the flow, of course. And there are 3 different types of flows that you can see here. We have a standard flow, which is ideal for, general purpose application. We have chat flow, which is designed for conversational application. And we have evaluation flows, which are focused on performance evaluation. Another categorization we can do for flows is flex flow versus tag flow. So with the DAG flow, user can basically drag and drop in UI to create a large language model application. So they have two ways to visualize and data flow: through a YAML file whose extension is dag.yaml, or through the UI provided by Azure Studio or the prompt flow extension of Visual Studio Code. If you tried prompt flow before the latest product release at build, that's the kind of experience you tested. Because a flex flow is a new pure code experience where user can define a Python function or class as an entry point of the flow and directly test it with pure code experience in a flex.yaml file. And the benefit of using this new flex flow is that it allows a more advanced orchestration with Python built-in control operators like if, else, or for each, and also a smoother integration with other platforms like LangChain and Semantic Kernel. Another cool new feature that I would like to present that has been announced at Build is the tracing feature of prompt flow. This feature records specific events or the state of an application during execution. So it can include data about function calls, variable values, system events, and more. So traces help break down an application's component into discrete inputs and outputs, which is crucial for debugging and understanding an application. It is integrated into the graphical user interface when running a flow in Azure Studio, while in code it can be simply enabled with a Python decorator. So by saying that, let's jump again to our Contoso chat retail. So let's jump again to Visual Studio Code because I would like to show you the code of this solution. First of all, the source code of our flex flow, because in this solution we are using a flex flow. We have a chat.prompty file, which is of course in the same format we have seen before with our very first prompty file. So you have a YAML in here with some metadata information, the format of the input, and then we have the sample input with the system message, so the instructions for our Contoso outdoor agents, where Contoso Outdoors is our fictional companies of hiking equipment. And then we have some safety guardrails. We have a dynamic section where we are going to add the context, so the retrieved items, relevant items to the user query, extracted from our retrieval system through a hybrid search. So a search which is a combined kind of search between vector search and the keyword search, which is enabled by Azure AI search. And then you have in here the history of previous orders. Again, this is retrieved by another data source where I have information about the customer, and so on and so forth. I have some other instructions and of course the chat history. I'm going to append dynamically the chat history. So we have this prompty file, and then the other thing is the YAML file with which is the actual flow definition. In case of the flex flow, this definition is very much smaller and simpler with respect to the DAG flow. In fact, what we have is basically the information about the inputs, and then the function, the Python function we are using as entry point of the flow, which is defined in this chat request.py Python file. So if we look for the entry point function, which is in our case, it's called getResponse. In here, you can see that this function basically get the customer information from the customer ID, looking into a Cosmos DB with information of the customer, get a conversation of the user query into an embedding, which is a numerical encoding of my user query used to optimize the search process. And then it gets the context, which means it used the question in raw text and it's embedding to perform a hybrid search in the product catalog index and retrieve the context to append to my prompt. And then I have the model configuration, so all the parameters around my Azure OpenAI model I'm using, which is GPT 3.5 Turbo. And then I'm going to basically, this function is going to basically load my prompty file and create an prompty object with, so basically filling in all the variables and placeholders you have seen in the prompty file with the actual inputs, which are the user query, the customer information retrieved from the Cosmos DB, and the context of the product's catalog relevant to the user query. Great, so this is all I wanted to show for the Contoso chat retail. So let's get back to our slide deck and let's come back for a moment to our large language model operations workflow with the tools and examples we have looked so far. We were able to mostly cover the first two phases, so ideation and building. But when it comes to actually operationalizing the application for production scenarios, there's a couple of additional tools that might be very helpful. And the first one is application insights that help us monitor performances and cost of our application into productions. And we can also build a dashboard with Azure Monitor to easily identify any issue or unexpected behavior. And the other thing is we can build continuous integration, continuous deployment pipelines with GitHub Actions to evaluate and deploy the application every time you push any edits to your GitHub repo. So let me wrap up. We have seen a few things, but let me wrap up this session with a recap of the tools we have explored today. First of all, Prompty, and you can see in here also a short link to the documentation, Azure Developer CLI, and the AI templates that you can use, as starting point for your own projects. And then PromptFlow, which is an example of an AI orchestrator in the Azure ecosystem. So in here you can find the documentation and examples for all the things we have covered today. And finally, I would like to recall that this is just the first episode of a whole series, which will span throughout June and July. So be sure to mark your calendar for the upcoming episodes, which will deep dive into DevOps and AI. And you have here also the short link to the whole series. So make sure to reserve your free spot for the upcoming episode. And with that, I would like to wrap up and thank you all so much for joining us today.